little bit.
Welcome, Abyss. How are we doing out there? We're missing some people. Haley Reed, if you're listening. Olivia Krepp, if you're listening. Who else is gone? Alex. Taurus, how are you doing out there? We're missing you. There I'm going. Alrighty. Alrighty. Who else? Alex, Olivia, Flora, Rachel, Carter. Hope you guys are having a good time. I know some of you are in Washington, D.C. Will you say hello to Mr. Trump for me?
You forgot Ryan.
Oh, that's awkward.
Ryan.
Ryan Kaluski.
Ryan
You really
Kaluski!
forgot Ryan.
Sorry. Oh,
Really
that's a
awkward.
bad moment, Ryan.
That was really awkward.
Sorry about that, Ryan. Well.
He's like, you got it.
You know,
Wait,
Ryan, if you haven't figured out I'm not perfect, that's just the way it is. Alrighty. We had done this problem, right?
Which one?
F, letter F.
Yep.
So if you have where it changes from, if they're negatives or alternates from negative to positive, you can just simply take the absolute value. So we're going to take a look at finding what the
You gotta move
nth,
it back down.
the nth
Are
term.
you just eating peanut butter with the spoon?
Yeah. And an apple.
That's awesome.
Yeah, that's her breakfast this morning.
Good breakfast.
Yeah.
It's quite healthy,
Yeah.
actually.
So I'm going to show you some methods. I think the best method is just kind of being able to see if there's a pattern. So on this particular one, obviously I have a fraction here. And a sub n, I have 1. And so this is the part that's changing. And you have to remember for this term, n is equal to 1. For this term, n equals 2. For this term, n equals 3. And for this term, n equals 4. And n is my input. So what can I do to get 2? I get 4. Well, if I look at 2, 2 is 2 to the first, 4 is 2 to the second, 8 is 2 to the third, and 16 is 2 to the fourth. So what's changing is this exponent from 1, 2, 3, 4. So a of the n could be written how, Sean Sheen?
1 over 2 to the n.
1 over 2 to the n. So now if I take the limit as n goes to infinity of 1 over 2 to the n, I would get what, Sean?
You get 0.
0. Which means that this sequence, these terms are convergent. Would you agree?
Yeah.
All right. All right, this next one, let's take a look at this. A sub n. So if I take a look at these terms right here, they look a lot like the terms that I had up here, correct? So I could say what I have here is 2 to the n. But what do I have down here? I have 1, 3, 5, 7, correct? And they're increasing by a constant term, which is 2. If they increase by a constant term, that means this expression is linear. So I know this, that I know this expression right down here is 2 times something with n in it. Well, if I take a look, I can actually view this term right here as 1 comma 1. My first term is 1. My second term is 3. My third term is 5. So I can view them as a set of ordered pairs. Does that make sense? So this is n, this is a sub n. So using what I call slope-intercept form, I can write it in that form, which is 2n minus 2 plus 1, which is 2n minus 1. And now I can check. If I put 1 in for n, do I get 1 as an answer? If I put 2 in for n, do I get 3 as an answer? If I put 3 in for n, do I get 5 for an answer? And I do, don't I? Right? So now I have this, 2n minus 1. These are called explicit forms. So if I would want to know the 100th term, if I would want to know a sub 100, it would be 2 to the 100th over 2 times 100 minus 1, whatever those would calculate to. But I'm more interested in determining whether it's convergent or divergent. So I'm going to take the limit as n goes to infinity, Deva, of 2 to the nth over 2n minus 1. What do you think? Infinity. How did you determine infinity?
First, I substituted infinity for n, and it puts infinity over infinity. So then I use.
Okay, so you took the look to see if you have a form in which you use L'Hopital's rule.
Yeah.
Okay, and then what did you do?
And then I found the derivative of the numerator and the denominator.
And the derivative of this is what?
2n times ln of 2.
Right. The natural log of 2 times 2 to the n, and the derivative of this is
2.
2. And so when you do that, you'll get infinity over
2.
2. So this you would say is divergent. Alrighty. Let's go to the next one. I gotta get caught up here on my notes. I'm a bit behind. So I think this one is the toughest of them. And so again, some people are able to determine the pattern by looking at it, and it looks really easy. 2, 4, 8, and then all of a sudden you see 15, and you expect 16, correct? Right? So what I did is I looked at these first 4 terms to come up with my pattern. I first thought it was going to be this. I thought, okay, it's going to be a to the n equals 1 over question mark. And then I realized I couldn't find a way to get this to be 15, so I had to look at it in a different way. So I took the first 4 terms and I multiplied them by 6. Excuse me. Hello. For the same reason?
I'm getting my mom's credit card information right now.
She's getting her mom's credit card.
I have it all filled out. I just need
She's
to
it
pay.
all filled out. She's just ready for her mom to take care of it. Yeah?
Do I still have to go down?
Okay. I will tell her that, okay? Okay.
It's for my AP test. Yeah, I know.
If it's not done by 11:59 tonight, they can't order the test.
Got it.
So you
Okay?
do by
And then there are other dominoes that fall.
Yeah, I know. Then I have to switch classes.
What?
I have to switch classes.
Yeah.
That's
Okay.
dumb. Why can't
Okay, okay.
classes?
You know, we're
I'm
know,
I'm not yelling,
You
I'm
know-
yelling at the world.
we're live, right? And these are being recorded for all time. So in 2 million years, there's talk about, why is this girl upset?
Should I go into the whole explanation of AP testing and what college credit is back now? I can do it. I can go on and rant.
Alrighty,
People of-
I am changing.
People, listen up, people of the abyss. I have something to tell
Listen
you.
up, people of the abyss. Alrighty, so I'm going to go through and how I figured this out. And I looked at it this way. I multiplied everything by 6. So this became 6/12, 6/24, 6/48, and 6/90. And then the reason I did that is because I realized that 12 is 2 times 6. 24 is 3 times 8. Hi, Matt. Matt, you know we're live on the Abyss.
Ooh, fun.
Are you kind of excited?
Yeah.
All right, this is done. So we're almost, I might be able to put your grade in tomorrow, or even earlier called today.
Perfect.
All right, super.
Thank you.
Yep. So here I have 4 times 6, and here I have 5 times 18, I believe, isn't it? In fact, I went even further, and then I said, well, this would be 6 times 26.
Oh yeah. I think.
Yeah.
Do you mean 4 times 12 for the 48?
Or 6 times 8.
Yeah, where there should be 12. Sorry. Yeah, 4 times 12 is 48, not 4 times 6. Well, then what I saw is, okay, now I got a sub n equals, here I have 6, and then I looked at this term, 2, 3, 4, 5, 6, and said that's simply n plus 1. So here's n plus 1. Times something else. So now my focus becomes, okay, what is this? These numbers, 6, 8, 12, 18, 26. My pen's running dry, so I'm going to switch pens a little bit. And I looked at their common difference. So this is 2, this is 4, this is 6, this is 8. I don't know if you remember me showing this last year. Since this is a constant, it's not linear. But if I look at the next column, they're all increasing by 2. That's where I have a constant. So I know that these terms are formed by a quadratic. And a quadratic is going to be in the form of an squared plus bn plus c. And again, since this is the first term, I can look at these as ordered pairs, 1 comma 6, 2 comma 8, and 3 comma 12. And the reason I picked 3 points is because I have 3 unknowns. I have an A, a B, and a C I'm trying to figure out. So I plug in 6 in for Y, and I plug in 1 in for N. So I'm going to have A plus B plus C. And then I'm going to put 8 in for Y, and I'm going to plug 2 in for N. And that's going to give me 4A plus 2B plus C. I'm going to do the same thing with the third point and get 12 equals 9A plus 3B plus C. And then what I'm going to do is I'm going to subtract these equations. So if I subtract these equations, in other words, if I take 8 minus 6, 4A minus A, 2B minus B, and C minus C, I get an equation that looks like this. 2 equals 3A plus B. And if I likewise do with the next two, I'll get 4 equals 5A plus B. And I'm going to do that one more time, and I get 6 equals 2A. So I know that A is equal to 3.
So wait, you subtract the full equations?
Yep, I take these two and I subtract them.
Okay, but then you add
No, I subtracted those two. I took,
Then it would.
oh, it'd be, excuse me,
Two.
2. You have to be able to subtract, this is 2.
That's 2 and then the next one.
And then the next one's going to be 1. You have to be able to subtract. And obviously I showed you that how not to subtract. So A is equal to 1. So then what I can do is I could just come up to this equation and say 2 equals 3 plus B, and B equals a negative 1 if I did that correctly. Then right here I know that A is 1, right? So I have 6 equals 1 plus a negative 1 plus C, so 6 has to equal C. So my equation that I'm going to look at is going to be n squared minus n plus 6. And that's a real messy one.
Yeah, I never would have just like thought to multiply it by 6.
Okay, and the reason I show you this is that you have an experience. Say, oh yeah, when he was really stuck, what he did is he multiplied, and what I did is I actually multiplied by 2 to see if I could find some type of pattern. Multiplied by 3, multiplied by 4, and I find multiplied by 6. And when I broke it up into this part like this, then I knew I had a way to solve it. So it took a little bit. I mean, from my part, it looks a lot easier, but it actually took me a little bit of time. And I'm just showing you a process. Now, when you get an AP question, you're not going to get an AP question that's like this because it'll take you about 3 hours to figure it out. And you don't have that time. But again, you can see now that if I take the limit as n goes to infinity of a sub n, then I'm going to get 0, so this is convergent. All right, so I'm going to look at the next one, which is an alternate one, and I'm going to show you how we deal with that. So the first thing we do is I write a negative 1, and I'm going to raise it to the n power. So when n is odd, like on the first one, the third one, and the fifth one, my answer is going to be negative. And on the even ones, it's going to be positive. Now, if I wanted this to be positive in the beginning, I would make this n plus 1. So it would be even. Does that kind of make sense? All right, and then I'm going to take a look at these terms. And I said, all right, let me look at 2, 8, 26, I'm giving my 81, and 242. Well, the ones that caught my eye right away were 8 and 26.
It's 80, not 81.
Oh, it's 80, yeah. And 80. And the reason why is I looked at 9, and I looked at 27, and I looked at 81. So this is 3 squared. This is 3 cubed. This is, like I said, 3 cubed. And this is 3 to the 4th. Then I said, well, I'll take a look at this. Squared, cubed, 4th. What is 3 to the 5th? That's what I asked myself. Well, I saw that was 243. So these are 1 less than 3 to some power. So I said, well, this has got to be 3 to the n minus 1. Is that kind of making sense? And again, a lot of that was experience. Now, what about this? 1, 2, 6, 24, 120. Well, 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. 24 times 5 is 120. So in other words, this 120 is 5 times 4 times 3 times 2 times 1. Here's my 6. Here's multiplying by 4. Here's multiplying by 5. So this is 1 factorial. This is 2 factorial. This is 3 factorial, 4 factorial, and 5 factorial. So what I have down here is n factorial. Are we doing okay? Now, even though it's sometimes negative and sometimes positive, for sequences, all I have to do is look at the limit as n goes to infinity of the absolute value of a sub n. In other words, I can ignore the negative symbols. And if you take a look, these terms, the numerator, and to be honest with you, I did find out there's a derivative of a factorial, because I always wondered about that, and I used to know its name. I think it's called the zeta function, but I'll look for sure. I got a feeling I might be wrong. And once you develop a function, you can take the derivative of it. But I do not know right now how to take the derivative of a factorial. So we look at it a different way. And if you look on these terms, the numerator is greater than the denominator. But if we keep going on, the next number I would have 720. Correct? So what is 3, 1, 2, 3, 4, 5. What is 3 to the 6th minus 1? Can somebody do that on their calculator for me? 3 to the 6th minus 1. What is it? 728. So now take a look. These gaps are narrowing, right? So now what I'm going to do is I'm going to multiply it. I multiplied this by 6. I'm now going to multiply it by 7. So if I multiply that by 7, I think you get 5,040. Now if I take it raise 3 to the next power minus 1, what am I going to get? 2,186. Now this is going to keep getting bigger, and this is not going to grow at the same rate. It's going to switch the other way, isn't it? So I've already capped out this numerator. The denominator is going to get increasingly bigger faster. So what's bigger than exponential growth? Factorial growth. Because rather than multiply by the same number, you're multiplying by a number that gets bigger by 1 every single time. And so it's going to grow even faster than that. It's a faster growth than an exponential growth. And so what happens to this limit? It ends up going to 0 eventually, the sequence. All right. Okay. Let's switch to the next part, and I think we're getting towards the end here. Is this the last page? Yeah. So we've talked, last year we talked very, very, very briefly about what monotonic means. Okay, so I'm going to give you some pictures of what monotonic functions are. Monotonic functions look like this. That's a monotonic function. This is a monotonic function. A parabola is not. Anything that has a turning around point or a relative min or max is not. So what is true about these functions? What do they have in common? Anybody want to take a guess? Yes, these two functions.
They only move in one direction.
Right. So in this one, we would say it always decreases. This always increases. That means it's monotonic. Okay? Now, if this always decreases, and I'm going to say F always decreases, what can you tell me about what has to be true about F prime? It must always, in this case, it must always be what?
Negative.
Negative. And this one, F prime, must always be positive. So if your first derivative is always negative or always positive, your function is monotonic. It's always increasing or always decreasing. Okay?
Horizontal lines,
Horizontal lines have no increase and have no decrease
so they're not monotonic.
because they have, because 0 is neither positive or negative. Okay? It's the only number that does not have a sign, and it's so those derivatives are always 0. Okay?
So it's not monotonic.
It's not monotonic. Okay? So now let's take a look at this function right here. Let's look at a real basic one. 2, 4, 6, 8, 10, 12. Okay? This is always increasing, correct? Right? And if you took the derivative of that, the derivative would be 2. Would you agree with that? Which is always positive, correct? And so this is also a divergent sequence. Would you agree with that? Monotonic divergent sequence. And it is bounded because my smallest number is 2. So it has what we call a lower bound. All right? So some sequences are bounded, have a lower bound, some have an upper bound, some have both. And we're going to look at those. All right? So let's take a look at this. So anyway, I give you some terms. A sequence is monotonic when its terms are strictly increasing or its terms are strictly decreasing. So again, that means the derivative is always either negative or the derivative is always positive. A sequence is bounded above when there is a real number m such that for any term it's got to be less than or equal to that number. That number is called the upper bound. A sequence is bounded below when there's a real number where a sub n is always going to be bigger than that number, and that's called the lower bound. A sequence is bounded when it's bounded above and bounded below. So this is the one, I forgot who gave this to us yesterday, where we went, oh, it was Alex. He said it was 4, 6, 4, 6, 4, 6, right? Dot, dot, dot. Remember that? And that's what A sub n is. So this would be bounded. Would you agree? It has an upper bound and a lower bound. The lower bound is 4. The upper bound is 6. What about this one? So if I put the numbers in here, did we do this one in class yesterday? David, did you do this one for me yesterday? Am I right? Did we have a -1, and then we had
-2, -1,
a -2, a -1,
-6 over 7.
a -6 over 7,
-4 fifths.
-4 fifths.
-10 over 13.
Okay, and then we stopped there and we went on, right? So does it have a lower bound? What is it? -2. In fact, you can say -3 is also a number, right? Okay, it simply says, is there a number that is less than or equal to it? Well, you could say a -100 is less than it, right? But usually what we choose as the lower bound, the biggest number of that group, which would be a -2. Does that kind of make sense? All right. Does it have an upper bound? Can this ever get to 100? No. So that would be an upper bound, right? Can it ever get to 1? No. Can it ever get to 0? I don't think so. What does it? It approaches a -2/3. Okay. Okay. Who else has not paid for their AP? Hello. She's in Washington, D.C. Okay? Yep. So this is bounded. This is also bounded between -2 and a -2/3. Right? Because that was the limit. That's what it was approaching. Correct? All right. What about this one? What did we find out? What was our first number? 1. 4/3. 9/7. 16/15.
And
25 over 31. Okay. Dot, dot, dot. So is that bounded? Does it have an upper bound? What's the biggest number? Well, didn't it start at 1, right? And then went to 4/3, 9/7, 6/15. Could this ever be 2? It can't be 2, can it? So it does have an upper bound, because 2 is an upper bound. Is there a smaller upper bound than 2? Well, here's 1, but we got bigger than 1 at 4/3, correct? And then 9/7 is 9/7 bigger than 4/3. I think 4/3 is bigger than 9/7. And then it starts getting smaller, correct? So it has an upper bound of 4/3, and it has a lower bound of what? Well, I think we used L'Hopital's rule, didn't we? Because if I take the derivative, I'd get 2n. Here I would get the ln of 2 times 2n. So I would take the derivative again. I'd get 2, correct? Over the natural log of 2 times the natural log of 2 times 2 to the nth, correct? And when I take that limit, I get what? 0. So it has a lower bound. This is the upper bound, a u b, and it has a lower bound of 0. Notice that B and C converged, correct? Now, the reason they converged is this was not monotonic, was it? It increases, then decreases, increases, then decreases, increases, and decreases. As we went here, this started to decrease, didn't it? As we started here, it started to increase, didn't it? So, bounded monotonic sequences, if a sequence is bounded, it has an upper bound and a lower bound, and is monotonic over a period of time, then it converges. So let's look at this one. What's the upper bound? What's the biggest number it can be? 3, right? Because we start with 1, correct? So the upper bound is 3. What's the lower bound? 0. That's its limit, correct? Is it monotonic? Is it always increasing or always decreasing? It's decreasing, correct? So it converges. What about this one? Well, if I listed them, I would have 1/4. I would have 8 over 7, is that correct? Then I would have 27 over 12, I believe. And then I have 4 cubed is 64 over 19. So is there an upper bound? No, because this is going to keep getting bigger, right? And I also know that because when I take the limit, the degree of the top is greater than the degree of the bottom. So there's none. It has a lower bound only. And that lower bound is 1/4. So this diverges. And this is the one I had above where it went 4, 6, 4, 6, 4, 6. This has an upper bound of 6, a lower bound of 4, but it doesn't, it's not monotonic. So it diverges. Okay. All right, so some terms and some stuff to take a look at. I gave you yesterday's assignment, so I think I need to stop this, baby. Goodbye, Abyss. See you tomorrow.